So very well done, everybody. You're all keeping up to date really well. I think we've got into a good routine. So I'm really pleased with the progress we're making. To be honest, I think we're going at about the same pace as if we were in school. So really, we haven't been too put out by the fact that we're in lockdown. I guess it's been quite handy that where we were in the scheme of work and the topics we had to cover aren't hugely difficult. So it's not like there's anything where I really need to be helping you too much. It's pretty straightforward, just needs a bit of practice. So, but still, well done, everybody. It's it's great, and thank you very much for lots of you who are uploading your work. That really makes me feel I'm sort of in contact with you, that I can actually see your notes and everything. So that's good to see. So what we're moving on today, and we're moving on to there's an extract from the scheme of work. So the scheme of work is really, we're looking at a whole bunch of other types of graphs. Okay. Now, when it comes to it, the cubic graphs are the most common ones that come up. So I'm going to set a couple of Hegartys over the next couple of lessons on the cubic graphs. But I do want to run through the other types of graphs now. So we've seen them all, but I'm not planning on setting Hegartys on types. So I'm going to keep that to the cubic graphs. So before we look at these other types of graphs, let's just remind ourselves about the ones that we are familiar with. If we get something like y equals 2x plus 4, that really falls into the brackets of being like y equals mx plus c. We know that's a straight line graph where 2 represents the gradient, the positive number, so it would be going up from left to right, and the intercept on the y-axis would be plus 4. So we're very familiar with straight line graphs. Done lots of work on y equals mx plus c. And the other thing that we're quite familiar with is where we've got quadratic graphs. Now remember, that's where we've got an x squared. And again, you remember that if it's a positive x squared, doesn't matter about the coefficient of x and then the number on the end. If we've got a positive x squared, that gives us a positive parabola shape, smiley face. However, if we had a minus x squared, then we would be getting a negative parabola, a sad face. Okay, so those are the graphs that we've really seen in our travels to date. Now, what we're going to be looking at today is cubic graphs. So that's where something's been cubed. So if we just picture the most sort of basic cubic graph, y equals x cubed, when we've got a big negative x value, say minus 10, minus 10 cubed is minus 10 times minus 10 times minus 10. That is a negative, so that would be minus 1,000. So you can see as you go along to minus 10, you very quickly go down to a very big negative number. Then as you approach negative, as you approach the origin, you can see that minus 1 gives us -1, and 0 would give us a 0. And then when we get into the positives, again, it climbs very steeply. It's not long before you've got a very high positive y value for quite a low positive x value. So that is the shape of a classic pure y equals x cubed. So just be clear in your mind, y over here, when we've got a negative x, we get a negative y. It's because we're cubing it. And obviously over on this side, it's fairly similar at this side to a quadratic graph. That could be half a smiley face, but it's just climbing much more steeply. Now, when you go and get a cubic graph like this, so we've got some extra terms, this is the shape it will be, okay, where we will be having 3 solutions where it crosses the x-axis. And we will do work later on GCSE, and for those of you who do A-level, we'll do quite a lot of work on finding these solutions here. Okay, but note the general shape is kind of the same. We've still got it as we're going into the negatives. We get a big negative y eventually, and once we get past this dip here, as the x's get bigger, we're getting big x values. Okay, so it's still the general shape that when it's a positive x cubed, it's positive over here. negative, negative over here, but with a couple of bumps. Now, it may be that they give you, excuse me, this cubic graph already factorized, and we will learn how to do that later. So if it's already factorized like this, then it's very easy for us to see what the solutions are where it crosses the x-axis straight away. How do we make this bracket 0? That is when x is positive 2, so it's cutting at positive 2. How do we make this bracket 0? Cutting at positive 1. And then how do we make this bracket 0? That's cutting at x being minus 2. So if it's already factorized, just to sketch the shape showing the where it crosses the x-axis is pretty straightforward. Clearly, for us to be able to sketch this one properly, we would need to be able to factorize it, which, as I said, we'll learn later. Of course, you could plot it. You could just do a series of x values and work out the y values just to get the general shape. So I just want to touch on some other types of graph, but as I said, I won't be setting any work on these at the moment. Now, this is called a reciprocal graph, where y equals, say, 1 over x. Now, when you get something like this, again, you've just got to gather your thoughts, okay? When x is a very big negative number, 1 over a very big negative number gives you a very small negative number. So as we get very big over here into the negatives with the x's, we get a small negative number on the y's. And as we approach the origin with the x values, say when you get down to minus 100, you would actually get a minus 100 as your coordinate. So we get this shape like this. Similarly, over once we get into the x values, where we've gone and got a very big x value, say 100, where x is 100, y is going to be 100th, which is a very small positive value. So you would get the coordinate 100, 0.01. And similarly, when you've got a very small x value, say 100th, 0.01, you would get 100 as your y value. So that's why we get this general shape like this. Now, there are two things to note here. When x equals 0, y is undefined. What 1 divided by 0 is not defined. It doesn't exist. That's why we put this dotted line down the y-axis, and that's called an asymptote, okay? And what we're saying is the curve is approaching the y-axis, but will never quite get there. Similarly down here, we'll never quite get there. Now, we also have an asymptote along the x-axis, because again, we'll be approaching it, but never quite getting there. There's just, again, just picture the coordinate, x is 1,000,000. Now, what is y going to be? It's going to be 1,000,000th. So that's going to be very close to the x-axis, but still just slightly above it, and similarly over here. So that's the general shape of a reciprocal graph. And we can also have a squared reciprocal graph. Say, for example, 1 over x squared. Now, that's very similar to what I was saying before, but because we are squaring the x value, they're all going to become positives. So nothing changes over here, this side, but over here, where we have a negative x value, the curve is no longer down here, it's now up here. But again, we have the two asymptotes for the reasons I gave before. So that's just a little introduction to 14.2. Okay, we've seen a reciprocal graph and a squared reciprocal function, but I'm going to concentrate our exercises on the cubic functions because they're much more common at GCSE and A-level. So today's Hegarty, please, is actually just going to be plotting these, okay? So you're actually going to have to go and work out some values, and then you will be just, obviously you can't plot it because it's a Hegarty, you just need to go and commit to what you think the y values will be. So that's just getting you to practice. I mean, I was minded to leave this one out, but I just thought that it's good to really drum home to you guys what shapes these graphs are. So just have a quick look of his video, please, in case there's some bits I've missed. And then if you could complete 298, and then our first lesson back after half term, we'll go and do the one that's a higher level skill, where we are just sort of recognizing the shapes of graphs. That's number, that will be 299. But don't do that yet. That's going to be after half term. Now, I was tempted to give you both of these to do today, but I just thought, whilst 298 isn't that difficult, it's quite time consuming. And I'm minded that really we've been instructed to try and keep the work you're doing, you know, to 25 minutes or so. So I think this will take you 25 minutes, even though it's not that difficult. Okay. So on balance, I've decided to keep it to 298 today, and we'll do, I think it's 299 next time. But don't go ahead and do that yet, please. If you want to do extension work, I want you to keep with the three things in mind. Anything you haven't done very well in yet, or you haven't had a chance to do yet, core book maths, normal GCSE, IGCSE work, and well done, one or two of you. You've started to do that, and you've been notifying me. You've been uploading it into class notes, so I can go and have a look. So well done, those of you who've started doing that. And then remember that the more difficult challenge, if you want to, is to start looking at that further maths work on functions. And I don't think anyone's done that yet, which is fine. I mean, I think there is a strong argument that maybe if you want to do some extension work, options 1 and 2 are the better ones. Catching up and doing some IGCSE, GCSE level work. And then, of course, we've got the further maths we'll be doing as a lunchtime activity next year. Okay, guys, that's it. So as always, I'll keep an eye out for your posts over the rest of the lesson. And again, make sure you say you hand it in when you've finished, so I then know it's okay for me to copy your mark over into my team's mark book. Okay, have a good half term when it comes, guys. You can go off and have your showers and whatever it is now. Okay, cheers, guys. Bye.